In this video, I'm going to explain how to get from a finite state machine to a circuit. So I'm starting with my finite state machine, then I'm going to take it to the state table. Then I'm going to create the equations for implementing the flip-flops, and then finally draw the circuit. So the first step is to analyze your state diagram. So I took this one right out of the Xi book, and you'll see that we have three states, M and P, right? So if you had to do the state encoding here, you would give it two bits, right? So it would be 0, 0, 0, 1, 1, 0. So go ahead and label that. If we had a fourth state, it would be 1, 1. So here, I want you to tell me what is the initial state. That's state M, or 0, 0. What is your input? Your input appears on your transition line, right? So that's what's going to get you from one state to another. In this case, A is our variable for input. Our output is labeled as S. So see here, S equals 0 at M, S equals 1 at N, etc. So S is our output, and then how many states do we have? In this case, we have 3 states, and because we have 3 states, we have to have at least 2 bits for the encoding, right? That's where this comes, numbering your states, 0, 1, 2. So that's 2 bits that are going to get us there. We can't do it in 1 bit. So that means you're going to need 2 flip-flops, one to store each bit in the encoding. So now we move over to the state table. So start with just labeling each of your columns. So first you're going to need to represent your present state. So you have a column for P1 and a column for P0, and that is representative of these 2 bits here. You also have a column for your input, A, then columns for your next state. So again, next state A next state is going to be labeled as N1 and N0. You will have 2 flip-flops to implement this, flip-flop A and flip-flop B. Next is your output S. And if we were to use D flip-flops, we could stop right there because the D flip-flop has only one input. So that would work here, right? This would be the input to the D flip-flop, and therefore then the output, it goes back into present state. But since I'm asking you to take this to one step further, which is to use a JK flip-flop to implement this, you're going to need 2 columns, one for J and one for K. So I have that for flip-flop A, and I also have that for flip-flop B. Next, start filling out your values, and as you can see in columns P1, P0, and A, these are your inputs, so I filled these out as we normally would. Next, go to your output. Remember that output is based on your present state. Remember, present state is what's in memory, so it's going to tell us what our output is. So at 0, 0, S's value is 0. So here's my 0, 0, these 2 rows. So this is also going to be a 0. At 0, 1, S's value is a 1. At 1, 0, that's the next 2 rows. 1, 0, S's value is a 1 also. Okay, and then what about these last 2 rows? What do we do here? If the state is unused, you can put your X's for your don't cares. So now go ahead and fill in your next state value. So I'm at 0, 0. My input A is a 0. Where do I go? So at 0, 0. Input A is a 0. Stay in 0. At 0, 0. Input A is a 1. I move over to 0, 1. Okay, I'm going to go ahead and fill these in and then come back. I went ahead and filled in the rest of these rows, so you'll notice that when A is a 0, you stay in the current state, and when A is a 1, you move to the next state. So I noticed that pattern. And then finally in the state 1, 1, 1, 1, right, that's not used, so you can put in your don't cares, your X's. Now go ahead and fill in the excitation column. So how do we do that? Well, present state 1 is a 0. Next state 1 is a 0. How do I go from a 0 to a 0, right? What do the inputs to the JK flip-flop need to be in order for that to happen? So this is where you would go to the excitation table, and I just took a snapshot of it. You can find this in your PowerPoint slides on slide 12. And so here on a 0, 0, right, if I want my present state is 0, my next state is 0, what do the values for j and k need to be? Right here, 0x. So I'm just going to fill that in here. 0x. So I went ahead and completed filling out the excitation values for j and k for flip-flop A and for j and k for flip-flop B. And again, the way I did that, so you're in present state 0, you're going to a 0. What do the input values for the j and k need to be? So you would just look here. I have an output of 0. I'm going to a 0. J should be 0 and K can be either 0 or 1. So that's where these values come from, right? So I have a 0, I'm going to a 0 again, 0 to a 0, 0 to a 1, that's where we change, and now we're 1x, right? So confirm that's correct, 1x. That's how I filled out the rest of these. So that's how you would fill out your truth table. In the next video, I'll explain how to create the equations using K-maps for each of these.